data-driven decisions. Let's talk about that. Alrighty guys, so after the last video on the ATC, I got a few comments or messages, whether it's on YouTube or Instagram, about this process, and some people think that I'm not doing the right thing, or that it's not bad and just put it back together and use it. And so to start this video off, I just wanted to make sure we're all on the same page on the story on how I got here. So if this was working, I would totally just use it and run it the way it is. But how this all started was when I tried to change tools. The tool rack, let me grab a tool here, when the spindle would spit out the tool, first it would be a really loud noise, like a kerplunk, and then the tool would just, I don't know if I can accurately show you guys, but it would just be hanging on by a thread on with the forks in here. And if I just touched it, it would just fall out. So that was the first issue I had. And then so I dug into it. I looked at the manual. I called FadalCNC. I also reached out to the guys on the Facebook group, and then started digging into the machine. And I found out that the Z height was off. Okay, so I adjusted the Z height. You know, we went up to the resolver. We go up there, up behind the spindle motor. I adjusted that and got the spindle height correct, that 50 thou height off the edge. And so I thought, okay, awesome, I'm done here. And so I checked different positions on the carousel, and I saw that it progressively got worse. And 180 from where I got set up, it was actually sliding up against the spindle nose, and I knew that was going to cause an issue because the forks were now way up here and not in that groove in the holder. So I dug deeper, and I think one thing that I forgot to mention or show you guys in the last video, which might have, you know, caused some of you guys to wonder why I thought this was bad. When I had the indicator up underneath and I was checking the height around the whole diameter, I didn't show you guys the math I did afterwards. I only showed you the actual indicator, which was right about here. I got math over here. I want to show you guys. Excuse me. So with that indicator up underneath the ATC, that's where you guys saw it started off at the 93 thou. And then I rotated the carousel all the way around, you know, see 21 pockets. And so I started off writing out the whole 93 thou, and then I got lazy. I just started writing out the number of where the indicator was. But the total deviation between the highest and lowest spot was about 12 thou. And where that was measured at was about 6.5 inches from the center of that carousel. I'll go over here. So it was about here. Now, as you guys know, that 50 thou gap between the spindle and the ATC is out here. So if I got data here, I want to extrapolate it out to, okay, what's that distance here that it's going to be off? So I did that math, and this is also just to document for my own sake. So if we, you know, simple fractions, 12 thou over 6.5 inches equals, you know, x over 11. Do the math, it comes out to about 20 thou. Now that doesn't explain the whole 50 thou difference between one side of the carousel to the other side. So I dug a little bit deeper. I found out that the spindle was not straight. Now the spindle and this are both connected, so if, you know, it can't just add up, you know, that deviation. This can't be out, and that can't also be out. Or I don't know if I explained that correctly, or clearly. But anyways, I checked this out, and that's when I came over here to the spindle, and I had all those marks on here that it's shaped like a banana. Oh, here's the new guy. So I bought a new ATC spindle. We're gonna go and install this in the machine, and then we're gonna go from there. But I at least just, you know, I appreciate everyone watching and giving their input, but I can't go without making, you know, data-driven decisions. I guess partially because I'm an engineer in real life, my day job, and so I like to dig down into, you know, the why of, you know, why is it doing what it's doing, and so that's why. So we're gonna change this out. I actually saw that this spindle from FadalCNC is actually a little bit different. You can see here, looks like it's a countersunk bolt. And I think, if I put this down, this is actually a separate piece from this. So, which actually might be helpful, because here is a little spot where the actual plate mounts up to. And if it does come to it to where, after replacing this, make sure that's straight, and we know this is pretty much straight, if it's still wonky to whatever degree, we can potentially use a shim. I don't like using shims, but up underneath this surface right here to kind of cock this to make sure it's flat at the plate position. So yeah, we're gonna do that. I got some grease. We're gonna grease the bearings down in there. Just make sure we got adequate grease in there. They're a little dry right now. And I'll probably repack the thrust bearings with the washers. And then we're also going to put these in the bevel washers. We're gonna go by the manual. Dang, I think I'm losing my voice. But we're gonna do the stacks of 6, so 3 and 3. They're, you know, 3 concave, 3 convex, or however you want to say it. And I think on the bottom there's a set of 4, and I think on the top side there's supposed to be a set of 4. And I figured out that I think I'm short one stack. But I think I'm gonna go with what I have right now to see how it comes out, because it was working to some degree before. If it comes to it, I'll get an extra 6 or so to add in there, and then we'll go from there. If I need to make more adjustments or figure something else out, we'll go along this, and hopefully I'll learn something and you guys will learn something maybe. So let's get set up, and we're gonna start putting stuff together. I got, what's the first step? Oh yeah, I'm gonna put the Geneva wheel back on that guy, and then we'll start stacking stuff up into here and then put the plate on. So let's get to it. Alrighty guys, so I think I found out why the bevel washers were the way they were. Let me go around to their side real quick. So, per the manual, you should have stacks of 6, at least for the VMC 15, stacks of 6 bevel washers. So 3 convex and 3 concave opposing each other. So 1, 2, 3, 4, and then up here, previously they had like a whole bunch of them all just stacked together, or they're in bigger chunks. And I think I found out why. Is, as you guys saw, I screwed this nut down all the way, and then I took it back off. You're probably wondering, why did you do that? Well, I found out that I bottomed it out all the way down, And if you look up here, something I was using as a marker to see how deep I was going was on the Geneva wheel, the actual, there's some grease that's missing here on the actual drive. And that's where this wheel was. And so when it's bottomed all the way out, that bolt up top, this wasn't going all the way up to here, which is where I'm assuming the correct position is. As far as, you know, where it needs to be in the Z. So in an effort to try and do this correctly, I'm just gonna go ahead and order the ones I'm missing as far as bevel washers, and then that'll help make up some gap here as a spacer and allow me to offset this nut a little bit further to be able to then, you know, clamp it all together. So I'm gonna go buy that real quick, and then we'll be back once it gets shipped in. So stay tuned. Alright, here we go. Moment of truth. I've aligned everything up here. I adjusted my Z height. And I'm about to do my first tool change. We're doing it live. I haven't done this yet, so we're going to see if we succeed or not. So here we go. TC, comma 1. Make sure everything's set. Alright, here we go. Rotating around. Alright. Going to rotate the turret around. I'm gonna go grab a tool. Make sure the dimple is out. Okay. There we go. See if we grab it. It worked! Alright, let's try it again. You know, once is a fluke. Twice is a coincidence. And then 3 times, that's when you can say maybe you start trending in a pattern. Rotate. And then grab that one. Yeah! Alright, I am happy with that. Let's wrap up. Alrighty guys, so we are all back together. I got panels back on. I got the top plastic piece back on. I put the resolver cover back on. And everything is pretty much all set. Everything over here, got all the bolts that I took out, you know, went back in. I wasn't missing anything, but yeah, I can now change tools and not have to worry about things dropping out or not aligning or whatever. As you guys saw, I got, you know, the tool change to change. I got the Z height adjusted, and I checked it in multiple locations. I changed tools over here. I did 180, and then I also did, you know, this way too. I guess 90 and then 180 from there, and I was able to change tools and not have to worry about losing anything. And then to try and correlate it back to my original measurements, I'm actually really surprised at what I got. And just to prove it to you guys, I got it set up here, and I'm gonna go around again. But we are at maybe about at the 31 thou mark here, and it actually moves a lot less after changing out the spindle and cleaning up everything and remounting everything. So let's go ahead. I'll rotate it around and you guys can see. All right, so I think that was 21. I was counting as I was pushing the button, but yeah, it moves. I think I saw right about 6 thou movement, and comparing it back to my other measurements before. So here's before, when I got all the measurements here, and my max deviation was about 12 thou. And if I go down here to post rebuild, I measured about the same distance out from the middle of the spindle, the ATC spindle, about 6 3/4 inches, about 6 thou total deviation between my highest and lowest spot. Doing the math, that comes out to just under 10 thou of movement, or displacement at the end of the ATC carousel, which kind of makes sense because I don't know if I showed you guys before, but I don't have a pair of gauge blocks or a pin to use for that 50 thou gap between the spindle and the platter. So I use this 50 thou Allen wrench, and I was able to just use it to go underneath between the pallet and the spindle, and was able to get that spacing. Now one side is a slightly closer than the other side. One side, this is just slides right in, and then one side you can see a little bit of, I guess, light on the top side of it. So there's a little tiny gap, which I was guessing was about 10 thou, and you know, maybe it's just coincidence, but my math here, you know, works out to be about 10 thou. But yeah, just an overview. We replaced the spindle, and then I also, you guys saw that I added the 6 extra bevel washers on top, which actually really helped pull things up and got the sensor aligned to the channel, as well as on the Geneva wheel in this proximate area, it lined up to the actual drive mechanism. So that was all good. Things are nice and tight now, straight. They rotate around. I can, you know, change tools out. But yeah, that's pretty much it. And I'm actually, this was a big mental hurdle for me for a while, thinking, oh my goodness, I got to do all this to take it all apart. But now I'm done. So now what's on the plate is doing more programming and getting stuff, you know, figured out. I really want to try out rigid tapping on here and or thread milling. but we'll probably do that, you know, of course, on a later video. Thanks for following along, guys, on this. It's been a journey. I'm hoping to get some local business now. You know, that I got this fixed, I'm more confident now to go and try and get more business into here, so I can change tools out and just have this thing running and then working on stuff on the side. But yeah, if you guys think this deserves a subscription, please feel free to click that subscribe button. You know, give us a thumbs up. And if you haven't already, also follow me on Instagram. I post a lot more on there than on YouTube. But yeah, until next time, I've got a whole workbench of stuff to clear off and some tidying up to do before we move on to the next bigger and better thing. So thanks, guys. See you guys next time. Bye.